In this session, we're going to take a look at EventSentry's file monitoring component, also referred to as file integrity monitoring or file checksum monitoring. The main purpose of this feature is usually to detect changes that are made to critical files, and that could be system files, for example, System32 in Windows, but could also be other critical files of sensitive software applications or even log files. You can also utilize file monitoring for automation. So if you have certain files that change for a specific reason and you want to initiate some sort of an action, such as launching a script, delete the file, compress the file, move the file, and so forth, then those are all things you can do with EventSentry. But again, primarily, file integrity monitoring is used to detect unauthorized changes to sensitive and critical system files. In the management console, of course, this will be present under System Health. This is a System Health feature. And by default, EventSentry will monitor the System32 directories in Windows, and it will monitor all exe and system files. So if we take a look here at file monitoring System32 64-bit, if we expand that package, of course, then we'll have a file monitoring object in there. And you can see that we're monitoring two folders in here. So we're monitoring the System32, which is of course for the 64-bit files, but then we're also monitoring the syswile64, which are 32-bit files. Before going to configuring that, let's look at some of the general options that are available for file monitoring. So the first option is how we're monitoring it, and by default we have it set to real time. So what that means is the operating system will let EventSentry, the EventSentry agent now, when a file change has occurred, and then EventSentry will do the rest. It will look at the file, will compare them with the previous version and so forth, and let you know what changed if you want to, and it will of course also update the database. If the real-time notification from the operating system fails, which is unlikely but possible, then you can also do a rescan at a set interval, 30 minutes by default. How often you set that interval sort of depends on the size and the number of files in the folder. If it's a very small folder with, I don't know, let's say a few hundred files, maybe a few hundred megabytes of usage, disk space usage, then a shorter interval, maybe 5 or 10 minutes would be fine. But if we are monitoring a large file share, for example, with gigabytes of files and tens or hundreds of thousands of files, and you probably don't want to be rescanning every single file every 30 minutes and have a higher rescan interval. Of course, calculating a checksum does take some time, and EventSentry uses SHA 256 checksums. And so the next setting here for under the advanced section is ignoring checksums for files that are larger than a certain size. You can tweak this if you feel comfortable with creating checksums for files that are even larger, 50 or 100 megs, then you can increase that number here. The other next setting here, only verify checksums when last write time changed. So this is the default and recommended. This will basically only verify a checksum if the actual last write timestamp of a file has been changed. And you can also further optimize it and say, well, let's only verify a checksum when the file size has changed. That's generally not recommended to be done because you could technically change a file and leave the file size, of course, the same. So if you check that checkbox, then EventSentry will never attempt to calculate a checksum, even if the last write time changed, if the file size has not been changed. So for security reasons, recommended to be off. The bottom left option, only verify incremental checksum and log files, is a new option, and that essentially is useful for log files where we want to make sure that they have not been tampered with. So obviously when we have a log file, and let's think about maybe credit card transactions, right? So you have a log, and every hour or every day or every few minutes, new information gets added to that log. So of course that would always trigger a checksum change or a file size change, which is not useful. But for these logs, of course, what we want to make sure is that the existing part of the log has not been changed, right? So if you have 100 lines in that log and you're adding 5 more, well, we expect that the checksum will change because the content of the file is being changed. Size increases, but we want to make sure that the first 100 lines have not been changed, and that's what that option does. If you check that box, then it will not get an alert if the file has changed when the file size remains the same, because it will only verify the checksum of the part of the file that has already been processed. And finally, on the bottom is where, of course, define into which database the data is going to get written to. So on the top, we have two folders, and we can edit those either by double-clicking or by hitting the plus icon. We can add a folder here. So I'm going to double-click that here so we can take a look at that. So first we specify the folder and indicate whether, of course, we want to include subdirectories or not. And then we get to the familiar inclusion-exclusion part of the dialog that you've probably seen in other parts of EventSentry, where we essentially define, well, what types of files, or which files do we actually want to monitor. So the first option would basically monitor every file, which would be a lot and probably too much and wouldn't be that useful. But you could go in and say, well, I want to monitor all files under System32, but I want to exclude all TMP files or log files and so forth. In this case, we went in and we're only looking at very specific files, which is exe and sys files, and also monitoring the host and lmhosts file. Okay, and notice how the path here is relative to the monitored path. So we're not going down there saying system root, system32, drivers, etc., hosts. No, everything that you specify here is relative to the monitored folder. So if a file is changed in the system32 directory and you want to create a filter to match that file, you'll have to essentially assume that your filter only applies to the part of the file that comes after the specified folder. That's why we have drivers, etc. hosts, for example. And then on the bottom, of course, we define, well, what do we actually want to get alerted on? File additions, file deletions, file checksum changes, and of course, file size changes, alternate data streams. So if you're familiar with this, NTFS allows the ability to essentially attach multiple data streams to a file. We can detect those. And then the file entropy. And the entropy is usually an indicator as to how random a file is. So for example, a text file will usually have a low entropy, whereas a zip file will have a high entropy. Why do we need this? Well, this can be very useful for ransomware detection because files that are compressed or encrypted will have a much higher entropy than a regular file. So detecting, for example, a lot of files with high entropy could indicate that some encryption or compression may be going on. And then for the alerting options, of course, we have the ability to say, okay, are we logging changes to the event log? With what severity? And we also have the ability to say, well, if a file is signed, then we want to automatically only log it as an informational event. Okay, so EventSentry can check that as well. But let's take a look at what this looks like in the EventSentry web reports. So on the file checksum status page here, you can access that under security and compliance file checksums. So even though it's a component that's configured in the management console under system health in the web-based reporting, since it's generally used for security reasons, it shows up under security and compliance here. So you just select that, select current, so that will show us the current status of all the monitored files. And I'm going to go ahead and pick our EventSentry server here again. We can see that we have the status of 919 files. We have a few groupings here already, whether they have digital signatures or not, whether any of these files have streams, and the file versions. But let's go into details here to see what we can actually view about the files. So here's some with Windows system files here, let's get an important one here, SMSS. So we can see the file version, we can see the file size, we can see the SHA-256 hash. We can see whether it has streams or not, the entropy, and also whether it has a digital signature or not. A nice little convenient feature is that you can click on the checksum and get immediately transferred to virus total, which will tell you whether there are any issues, any viruses detected for that checksum. You can see that we have various different values here for the entropy, since of course that depends on the actual executable, the size and the code that's in there. But like I mentioned, generally speaking, a higher entropy would imply that this file may be encrypted or compressed. Encrypted files usually even more higher entropy than compressed files. And let's take a look at a specific folder that I set up here. And that would be the DISM folder here. I'm going to search here, and we have 2 files in here. And I created this compressed file here just to illustrate, how the entropy works and how you can observe differences there. So basically what I did is I went into this folder and I compressed the DISM host.exe and just called it DISM host compressed. I gave it the exe extension just so that it gets picked up by EventSentry. So the first thing we can see is there's of course no file version because this is really a zip file. We can see the lower file size, we can see different hash, and we can see that it doesn't have a digital signature, of course, because it's a zip file really. And we can see the entropy difference. So this is actually the same exact file, except one of them is compressed, the other one is not. And you can see how the entropy is higher. So it's not that much, but it's getting close to 8, whereas most of the files we observed earlier were around 6 or 7 or even lower. So that's just an example of how compressing a file, for example, will change its entropy. But going back to our EventSentry server and looking at all files, one neat thing that is not necessarily security related is that you can compare files across all your servers. So if we say, okay, well, let's see which versions that sms.exe or the spooler service, let's start with that one. So we'll go in here, we'll hit the space key, we'll say file, we'll select the spool service. So now, of course, we just get one result. We have this version here. Now, if I remove the restriction for the computer and hit search here, now I get all the different versions of all the monitored servers. So some of them are the same versions on these 2 machines here, on the server 1 and DC1, and server 2. Since it's a different OS, of course, it has a different version. But that's a really neat way to compare a file across multiple systems. So if you have 50 2019 servers, for example, and you want to make sure, hey, are they all on the same version? Let's say a security vulnerability was just released about a specific file, and you want to ensure that they do have the latest version, then that's something that you can check with file monitoring. And the entropy shows up as 0 on these hosts because I haven't updated the settings yet on those remote machines. Only the EventSentry server currently has the entropy enabled. In addition to seeing the current status, you can of course also see changes to the files. So instead of going on current, we can go to history, and here we can see changes that have been made to the system. So let's take a look here at the detail tab. We're just going to look at everything. We're going to expand this here a little bit. And here we can see that, for example, a file was deleted and re-added. So this usually happens when you update to a new version of EventSentry. Same thing here for the agent. Here we can see that the old and the new file sizes are about the same, but the checksum has changed, for example, as did the entropy. And this is a way to basically review changes that have been made to the systems. So let's take a look at these 2 here. These are some Windows files that have been changed on server 2 here. We can see here that the file size was increased. We can see that the version number was increased here, so from 118 to 23. The size got increased from 803 to 914, and we can also see that the hash changed. And we can see that both of these versions, the old and the new one, have a digital signature. So if you want to review changes that have been made to your monitor systems, and that's a great way to do that. And of course, you can filter all of this out too, to say I only want to see files where the checksum changed. I can only want to see files, for example, like clicking here, for example. So now we will only see files where the checksum has changed. But back to the management console, if you want to monitor a different directory, then obviously I would leave those default packages in place, but create a new package and add the folders that you want to monitor, of course, to that package. For troubleshooting purposes, EventSentry does keep a cache of all the monitored files. So if we go and take a look at the system 32 directory here, where EventSentry is installed, and we look at the temp folder here. The file checksums are stored in this file. So even if you turn off, so even if you stop the agent and then make a change to one of the monitored files and then restart the agent will detect that change and still log it. If there's ever issues with file monitoring where something is not being reported correctly, or you are getting too many notifications about files that changed, then you can stop the EventSentry agent service, delete this file, and cause it to reinitialize the local cache. Normally that is not necessary, but that would be the troubleshooting step for that. This feature is usually pretty hands-off. However, do keep in mind that calculating an SHA-256 checksum does, of course, take some time. So if you are monitoring a large amount of files, and I'm talking hundreds of thousands or millions of files, then that may take some time, and it may, at least temporarily, cause a spike in CPU usage by the agent, because ultimately these checksums just have to be calculated, and that does take CPU time. And of course, there will be some file access activity as well if you're monitoring an extremely large amount of files. So this is not necessarily a feature that's intended to be used for terabytes of data. This is something that's designed to be used for critical directories, operating system directories like System32, maybe some custom applications that you have, or or directories where you're storing, for example, credit card logs or other sensitive information. It will work for larger folders too, but it may take more time and may just utilize more resources than you'd like. So that's just something to be aware of.